Hello everyone and welcome to the Blabber Cloud podcast, where we delve into the world of cloud security and explore the latest trends and best practices. In today's episode, we are going to talk about a key aspect of cloud security, that is AWS Identity and Access Management. IAM is a critical component of any AWS environment, as it controls who has access to what resources and at what level. But with the complexity of AWS and the constant evolution of cloud technologies, managing IAM can be a daunting task. So join us as we explore the ins and outs of AWS IAM, from the basics of identity and access control to the advanced features like zone of trust and access analyzers. We'll share tips and best practices for keeping your AWS environment secure, and we'll discuss some common pitfalls and how to avoid them. So sit back, relax, and get ready to dive into the world of AWS IAM with Blabber Cloud by Pythoholic. So when we talk about IAM is a web service that helps you securely control access to AWS resources. It allows you to create and manage AWS users and groups, and to use permissions to allow and deny their access to AWS resources. So that's a very basic understanding or definition of IAM. And one of the key benefits of IAM is that it enables you to create multiple users for your AWS account and assigns them different permissions. This actually allows you to better manage access to your resources and ensure that only authorized users are able to perform actions on them. And IAM also provides a number of built-in policies that you can use to grant permissions to your users and groups. These policies define what actions users can perform on which resources. For example, you can create a policy that allows a user to read and write to an S3 bucket, but not delete it. Additionally, IAM supports multi-factor authentication, which requires users to provide a second form of identification, such as a code sent to your phone, in order to access the AWS account. This actually helps to improve the security of your account by adding an extra layer of protection. And IAM is a crucial part of securing your AWS environment. If you're not already using IAM, we highly recommend taking the time to set it up and properly manage access to your AWS resources. And AWS is a service that helps you manage access to your Amazon Web Service resources, and it also enables you to create and manage users and user groups, and to use permissions to allow or deny their access to the resources. So imagine that you have a team of people working on a project together, and they all need access to various resources such as servers and databases in order to do their work. With IAM, you can create separate user accounts for each person on your team and specify exactly what resources they are allowed to access and what actions they can perform on those resources. This helps you to ensure that only authorized users have access to your resources and helps to prevent unauthorized access and changes to your environment. And IAM also provides additional security measures such as multi-factor authentication that I already told you. And in short, IAM is a tool that helps you manage and secure access to your AWS resources, and it is an important part of protecting your environment and ensuring that only authorized users have access to your resources. Now let's talk about the 3 A's in AWS IAM. Yes, the 3 A's. I'm sure you might be aware of that as well. So the 3 A's in AWS Identity and Access Management refer to the core feature of IAM. So they refer to the core feature of IAM, that is authentication, authorization, and accounting. So the 3 A's: authorization, authentication, and accounting. The first thing, authentication. So this refers to the process of verifying the identity of a user or device before granting access to the resource. So in IAM, users are authenticated using their unique AWS access keys, which consists of an access key ID and a secret access key. Second thing is authorization. So this refers to the process of granting or denying access to resources based on the permissions of the user or device. In IAM, you can use policies to specify which users or groups are allowed to access which resources and which actions they are allowed to perform on those particular resources. The third one, also very important one, that is accounting. So this refers to the process of tracking and recording user activity in order to monitor and audit resources or audit resource usages. In IAM, you can use CloudTrail to track user activity and generate logs of action taken on your AWS resources. So these three are really, really important: authentication, authorization, and accounting. So together, these features form the foundation of IAM and help you secure and manage access to your AWS resources. I know I've repeated this line so many times, but I think it'll be very helpful moving on. And AWS follows a certain type of access control, that is ABAC. So let's understand what ABAC is. So ABAC is your attribute-based access control. So that is a type of access control model that allows you to define policies based on the attributes of a user, a resource, and the context in which the resource is being accessed. So in AWS IAM, ABAC is implemented using IAM policies, which are used to grant or deny access to AWS resources. And with ABAC, you can specify the attributes that a user must possess in order to be granted access to a resource. So let's take an example. So you might create a policy that allows users with attribute department equal to marketing, or department equal to production, or department equal to business to access a specific S3 bucket, but deny access to users with the attribute department equal to HR or finance. You can also use context-based attributes such as the time of the day or the location from which the request is made to further refine your access control policies. So that's a very good thing. And ABAC, when it comes to ABAC, the best part about ABAC is that it provides a flexible and granular way to manage access to your resources, and can be useful in cases where you need to implement complex access control rules. However, it can also require more time and effort to set up and maintain compared to other access control models, such as role-based access control or RBAC or RBAC. So this RBAC is something that we would have already heard, or we might have already used it before when we might not be even working with AWS. But these are very important features that IAM provides. And one more thing we should discuss before moving forward is the least access privilege. So least access privilege is a security principle that states that users and processes should be granted the minimum permissions necessary to perform their required tasks. In AWS Identity and Access Management, or IAM, this means that you should aim to grant users only the permissions they need to do their job, and no more. For example, if you have a user who only needs to read data from an S3 bucket, you should only grant them read-only access to that bucket. Granting them additional permission, such as the ability to write or delete data, would give them more access than they need and could potentially introduce security risks. Sometimes what happens is the developers or the junior developers that we have might have additional permissions, and they, because of the lack of experience, they might delete some of the resources which might be important. But that responsibility is of the architect or the admin who is managing those resources. So we must ensure we should always give least access privilege to the resource or the policy that we have, or the user that is going to use that resource. And applying the principle of least privilege or least access privilege actually helps to reduce the risk of unauthorized access or misuse of resources, and can improve the overall security of your AWS environment. And it is an important best practice to follow when setting up and managing access to your resources in IAM. So that is the first step that you should take, getting the least access privileges. So that is the first and foremost action that you should take while managing the access to your resources. And some of you might ask me, like, if you're not using IAM, then you could ask me, like, why should we make use of AWS IAM? So there are several reasons why it is important to make use of AWS IAM. So the first thing and the foremost thing is security. So IAM helps to improve the security of your AWS environment by enabling you to create and manage users and groups, and to use permissions to allow and deny access to resources. So it's a control. So this helps to prevent unauthorized access or changes to your resources, and can reduce the risk of security breaches. So if you don't have access or don't have permission, you will not be able to perform the action. So that's pretty much the simplest way you can define that. Next thing is collaboration. collaboration is very important because you're not going to be the single person who is going to use the AWS account. So in collaboration, what happens is IAM makes it easier to collaborate with the others by allowing you to create separate user accounts for each member of your team and to specify the resources they're allowed to access and the actions they can perform. This can help to ensure that everyone has the access they need to do their job, while also preventing unauthorized access to the resources. Pretty much in handy, isn't it? So the third one here that we have is compliance. So IAM helps you to meet compliance requirements by providing features such as multi-factor authentication and the ability to track and audit user activity. So this can make it easier to demonstrate compliance with various regulatory standards and requirements. Let's take an example. So let's say you have a team of developers working on a project together, and they need access to various AWS resources, such as EC2 instances and S3 buckets in order to do their work. With IAM, you can create separate user accounts for each developer and specify the resources they're allowed to access and the actions they can perform on those resources. This actually helps to ensure that only authorized users have access to the resource they need, while also providing an audit trail of user activity that can be used to meet compliance requirement. So compliance is very important when it comes to working on a project, because the business part of the structure that you see on a project that you're working on, either it could be in AWS or usually work, the compliance is something that we have to pass, and there are standards based on which you need to comply or you need to pass those standards. Then only your product gets approved for the deployment into production. And as I already told you that you can create IAM user and user groups. So you might ask me like, what is the difference with that? So in AWS, an IAM user is an individual entity that you create in your AWS account. So each IAM user has a unique AWS access key, which consists of an access key ID and a secret access key that is used to authenticate the user's identity and allow them to access the AWS Management Console or to make programmatic requests to AWS APIs. So in order to use CLI or even to use Management Console, you need to be a user or you need to be a IAM user with those permissions. And an IAM user group is a collection of IAM users that you can manage as a single entity. You can create policies that apply to all of these users in a group, which can make it easier to manage permissions for multiple users at once. For example, you create a group of all the users in your marketing department and then create a policy that allows them to access a specific S3 bucket. And the main difference between IAM users and groups is that users are individual entities with their own set of permissions, while user groups are collections of users that can be maintained or managed as a single entity. Using user groups can help to simplify the process of managing permissions for multiple users and can make it easier to enforce consistent access control policies across your organization. So that's a very beautiful thing to have. And now that I've already told you so much about policies, so what is an IAM policy and why should we use it? So an IAM policy is a document that defines the permissions that are granted to a user or group in AWS identity and access management. It specifies what actions a user or group can perform on which resources, as well as any conditions under which those actions are allowed. So IAM policies are written in JSON format and can be attached to IAM users, groups, or roles. When a user or group attempts to access a resource, IAM compares the permission specified in the policy to the requested action and either allows or denies based on the result of the comparison. Now let's suppose you want to create a EC2 instance and the policy that is assigned to your IAM user does not have that condition. Then when you go ahead and try to launch an instance, then it'll throw an exception that you don't have the proper permissions, and that is how policies are defined. And there are several reasons why you should implement or you should use IAM policies. So first thing is security. So IAM policies actually help to improve the security of your AWS environment by enabling you to specify exactly which actions users or groups are allowed to perform and on which resources. This helps to prevent unauthorized access and changes to your resources and can reduce the risk of security breaches. Second thing is collaboration. So IAM policies can make it easier to collaborate with others by allowing you to specify the permissions that are needed for each member of your team to do their job. So you can define that policy and you can apply it across the team so that they know what they can do and what they cannot. And this can help to ensure that everyone has the access they need to do their job while also preventing unauthorized access to the resources. Third one, as I already told you before, compliance. So compliance is very important, and IAM policies can help you meet those compliance requirements by allowing you to specify the permissions that are needed to meet various regulatory standards and requirements. And the fourth one, and the most important one, is ease of management. Yes, IAM policies can be managed centrally and can be easily attached or detached from users, groups, and roles as needed. So this makes it easier to manage access to your resources and can save time and effort compared to managing access manually. Who is going to manage access manually? If you think of it, there might be like 100 or 200 users. You cannot just go ahead and go to each individual user and define the policy or permissions, right? So it's very good to use IAM policy there. So if you're defining policies for the users, so how does an AWS user make use of IAM? So an AWS user can make use of AWS IAM by signing into the AWS Management Console. So a user can sign into the AWS Management Console using their AWS access keys, which consists of an access key ID and a secret access key. The access key are used to authenticate the user's identity and allow them to access the AWS Management Console. You can also have the credential way of logging into the AWS Management Console based on the user ID and password that you have. That is also an option. And the second thing is use IAM policies to access resources. So an AWS user can use IAM policies to access resources within their AWS account. These policies actually specify the actions that the user is allowed to perform on which resources, and as well the conditions under which those actions are allowed. For example, let's take an example here. So a user might have a policy that allows them to read and write to S3 bucket, but they may not have the permission to delete it. So they can only read or write. Use multi-factor authentication. Yes, that's a third way. An AWS user can use multi-factor authentication, or MFA that we usually call, to add an extra layer of security to their account. So MFA requires users to provide a second form of identification, such as a code sent to the phone, in order to access their AWS accounts. So this also helps to prevent unauthorized access to the account. The next one also is a very important one, and you might also use it. So using IAM roles. Yes, an AWS user can make use of IAM roles to access resources in other AWS accounts as well. Yes, you heard it right. Using IAM roles, you can access resources in other AWS account, or to delegate permissions to third-party applications or services. So for example, a user might create an IAM role that allows a third-party vendor or service that they want to use. So that also can be useful. Now that we have already spoken about policies, let's talk about roles, which is also very important. So roles in AWS Identity and Access Management, or IAM, are a way to grant permission to AWS resources to AWS users, or to delegate permissions to third-party application or services. So roles are intended to be assumed by authorized entities such as IAM users, AWS services, or external identities. So the major difference that you see here is roles are intended to be assumed. So we assume a role. So it is attached to a particular IAM user or AWS service or external entities. And there are several types of roles in IAM, including service roles, EC2 role, IAM roles, federated roles, and organization roles. Roles are not like a chicken role, but these are roles. Like, let's suppose I am an actor and I am performing the role of a musician who plays guitar. So that's my role. And when I assume a role, I can perform the actions that are supported by the role. So each type of role serves a different purpose and can be assumed by a different type of entity. So roles are important because they provide a flexible and secure way to manage access to your resources. So instead of granting permissions directly to users, you can create a role with the necessary permission and then allow users or other entities to assume the role as needed. So this helps to reduce the risk of unauthorized access or misuse of resources and can make it easier to manage access to your resources over time. Then you would ask me like what exactly it would mean. So let's take an example here. So let's say you have a third-party application that needs to access an S3 bucket in your AWS account. So instead of granting permissions directly to the application, you can create an IAM role with the necessary permissions and then allow the application to assume the role when it needs to access the bucket. This helps to ensure that application only has the permission it needs to perform its required task and helps to reduce the risk of unauthorized access to your resources, because every role that you assume may come with a session time. So within that period, you'll be able to perform your operations, then it is well and good. Otherwise, the session would expire. And there are several roles or several type of roles that can be attached in AWS IAM. So the first one is service roles. Service roles are intended to be assumed by AWS services. They allow AWS services to interact with resources in your account. So let's suppose you are using a EC2 instance and you want to access your S3 bucket. Then you can create a service role, or you have service rules for that. And the next one is EC2 roles. So EC2 roles are intended to be assumed by Amazon Elastic Cloud Compute instances. They allow EC2 to interact with resources in your account. Next, we have IAM roles. So IAM roles are intended to be assumed by IAM users. So they allow IAM users to access resources in your account or to delegate permissions to third-party applications or services. Next is federated role. So federated roles are intended to be assumed by external entities such as users in your corporate directory. Sometimes we want to use Okta or IDP to provide an external authorization. So they allow external entities to access resources in your account. And the next one is organizational roles. So organizational roles are intended to be assumed by members or member accounts in an AWS organization. So they allow member accounts to access resources in the organization's management account. So when you use AWS organization, you have a hierarchy. So there will be a master, there will be like production that you create, under which there will be other AWS accounts. So within that also you can have which actually will allow member accounts to access resources in the organizational management account. So all of these roles are created and managed using IAM and can be used to grant or deny access to resources in your AWS account. As we have discussed till now, let's try and understand the differences between the role and policies as well, so that we can get a refresher once again. So in AWS IAM, roles and policies are two different ways to grant permissions to resources. So roles are intended to be assumed, as I already told you, by authorized entities such as IAM users, AWS services, or external entities or identities. So when an entity assumes a role, it is granted the permission that are specified in the roles policy. So roles are useful for situations when you need to grant permission to resources to entities that are not IAM users, such as AWS services or external applications. And policies, on the other hand, are attached directly to the IAM users, groups, or roles and specify the permissions that are granted to those entities. So policies are written in JSON format and they define the actions that an entity is allowed to perform on the resource, as well as in any condition under which those actions are allowed. So the main difference between roles and policies is that roles are intended to be assumed by authorized entities, while policies are directly attached to IAM users, roles, and groups. So this means that roles can be used to grant permissions to entities that are not IAM users, while policies can only be used to grant permissions to user, groups, or roles. So when you say that you are assuming a role in IAM, it means that you are temporarily taking on the permission and privileges that are associated with that role. So this is done using the AWS STS or Security Token Service, which allows you to request temporary credentials that can be used to access resources in your AWS account. So that's a very important thing. Remember, this is done using STS, that is Security Token Service, which allows you to request a temporary credential. So during that period, you get a temporary credential and you can use that to access the resources in the account. And there are several reasons why you might want to assume a role. So let's suppose if you want to access resources in other AWS account. So you can use roles to access resources in other AWS accounts that you have been granted access to. And if you want to watch more on how this has been done, you can go ahead and watch the video that we have. I have already explained about the policy there, the type of policy that we are going to use. So you can watch that video on the channel. It is already available to you. Just go ahead and type IAM. You will get the video for that. So the next one would be to delegate permissions to third-party applications or services. So you can use roles to delegate permissions to third-party applications or services, such as an external application that needs to access an S3 bucket in your account. So let's suppose you have hosted an application, that's a third-party application, and you're storing reports into S3 buckets. Then using this role, you can actually help that access an S3 bucket in your account. The next one would be to assume the permission of an IAM user in another account. Yes, this is very interesting. Like to assume the permission of an IAM user in another account. So you can use roles to assume the permission of an IAM user in another account, which can be useful in cases where you need to access resources in multiple accounts. So let's suppose you want to perform an action on different accounts, like a list of accounts, and you want to perform an operation like executing a CLI command, which actually modifies certain values in the VPC. So you can create a role which you can assume in other accounts. But in order to do that, you need to have that role already deployed in that particular host account, by which you can assume the role and you can perform those actions on that particular account, not being the user in that particular account itself. So that's a very big advantage that we have here. So using roles, you can assume the permission of an IAM user in another account, because when we have the trust relationship set up, it will identify you as one of their own, and it will grant you permissions based on the policies attached to that particular role. So when you assume a role, you are granted a temporary credential, as I already told you, that consists of an access key ID and a secret access key and a session token. So these credentials can be used to access resources in the account that owns the role, as long as they have been granted permission to do so. This is what I was trying to explain you. And the credentials are valid for a specific duration, after which they expire and can no longer be used. Now, as we discussed about roles, let's talk more about some of the policies that we have. So there are several types of policies that you can use in AWS IAM. So the first one would be identity-based policies. So identity-based policies are attached directly to an IAM user, group or role, and it grants permissions to that identity. So these policies are written in JSON and can be used to grant permission to resources in your account, as well as to specify conditions under which those permissions are granted. So that's a good thing. It's identity based. So it is attached to the identity. Resource-based policies. So as the name suggests, resource-based. So resource-based policies are attached to an AWS resource. Yes. And grants permission to that resource itself. So these policies are written in JSON and can be used to grant permissions to specific IAM users, groups, or roles, as well as to specify conditions under which those permissions are granted. So that's a very good thing. Identity based is attached to the identity itself, and resource based is attached to an AWS resource. Next is permission boundaries. So that's also very important. So permission boundary or permission boundaries are used to set limits on the maximum permission that an IAM user or role can have. So these boundaries can be used to ensure that users and roles do not have more permission than they need. So if you set a permission boundary, even if you define thousands of other allow policies, it won't work, because a single deny is enough to discard all the explicit allows. So that's something that you need to remember. If there is a deny, it takes precedence. Next is organization policies or organization policies. So organization policies, as I already told you, are used to set permissions at the root level of an AWS organization. So these policies are written in JSON as well to grant specific permissions to specific accounts within the organization. So overall, the type of policy that you use will depend on your specific needs and the resources that you're trying to secure. And the major difference between identity-based policies and resource-based policies are basically there are two types of policies that you can use in AWS IAM to grant or deny access to resource in your account. But the main difference between these two policies is how they are attached to resources. So identity-based policies are attached to an IAM user, group, or role, and they grant permissions to that identity. However, resource-based policies are attached to an AWS resource. So they grant permission to that particular resource itself. So suppose you have an S3 bucket that you want to allow users in your teaching group to access. So you have two options for granting access. So first would be the identity-based policy. So you can create an IAM group called teaching and attach an identity-based policy to the group that grants permission to the S3 bucket. So that would have, like, imagine it like having an effect equal to allow action S3 list bucket, and resource would be the ARN of that S3 bucket, and the effect would be allow for the list bucket and the get object operations. So you would then add all of those users in your teaching group to that teaching group itself that we created, and this would grant those users the permissions that are specified in the policy. Alternately, what you can do is you can attach a resource-based policy directly to the S3 bucket that grants permissions to that particular teaching group. So you got the difference. We are directly attaching something to the S3 bucket, but whereas we are creating a policy separately and attaching it to the group in the identity-based policy. Here in resource-based policy, what we are doing is we are attaching a resource-based policy directly to the S3 bucket that grants permissions to the teaching group. So this policy is also as well written in JSON and would have a special condition added, like a prefix where it allows only starting from a teaching. So if the group starts with teaching. So in the example that we heard, the main difference between the two type of policies is how they are attached to the resource, that is the S3 bucket. So the identity based policy is attached to the teaching group itself, while the resource based policy is attached directly to the S3 bucket. So overall, the choices between an identity based policy and a resource based policy will depend on your specific needs and how you want to manage access to your AWS resources. And we hope you're enjoying the show so far. Before we get back to the main content, we want to take a break to promote our YouTube channel and ask for your support. If you haven't already, please consider subscribing to our channel. We regularly post new videos on variety of topics including AWS, DevOps, and Python. Subscribing to our channel is completely free and helps to support the show. And it also ensures that you never miss an episode and get access to the exclusive bonus content. So if you are enjoying our podcast and want to see more from us, please head on over to our YouTube channel and hit the subscribe button. We would really appreciate your support and we can't wait to see you there. And if you have any other questions or feedback, we'd love to hear from you. Just leave a comment on the YouTube channel. And if you want to join this podcast, then please fill out the form. The link is provided on the video description below. Fill in the form and join me on the next podcast. So thanks for listening to this important message. So now let's get back to the podcast. So the next thing that I wanted to talk about is what is tagging in AWS IAM and why is it useful. So in AWS, tagging is a process of assigning metadata in the form of tags to IAM users, groups, and roles. So tags are nothing but key value pairs that you can use to classify and organize your resources. So tagging is useful because it allows you to add additional context and metadata to your IAM resources and to use that information to manage and track the resources that you have. For example, you might use tags to track the purpose or owner of a resource. So you can use tags to identify a purpose of a resource or to track who is responsible for it. This can be useful for identifying resources that are no longer being used or for tracking resource usage. So if it is no longer used and there is a tag associated with a particular user or owner, then you can easily identify which project or which resource it belongs to or which owner it belongs to. The next thing it would be helpful is to ensure access control policies. Yes, we already discussed attribute-based access control. So you can use tags to enforce access control policies by creating policies that allow or deny access to the resource based on their tags. So for example, you might create a policy that allows access to the resources with the department teaching or marketing, but denies access to the resources with the tag department finance. So next one that I'm going to tell you, the usage of tags. This is one of the most important ones because this is something that you also might be able to use or you might be using it in the future if you're going to work on AWS. So listen to this very carefully. Assign cost allocation tags. So this is one of the most beneficial tags to have. So you can use tags to track the cost of your resources and also to allocate those costs to specific projects and departments. This can be helpful for tracking and budgeting your or for resource usage. So this is a very important and this is one of my favorite tags actually, cost allocation tags. It could be the business cost or the product cost or the team cost, whatever it may be. You can attach the cost allocation tags and keep track of those specific projects or departments that you're going to push these budgeting reports forward to. So overall, tagging is a useful tool for adding additional context and metadata to your IAM resources and for organizing and managing those resources more effectively. And that's why we discussed about ABAC, that is attribute-based access control. And as I already told you, we had RBAC, so which is a type of access control model that allows you to grant permissions to users based on their role within an organization. So let's suppose you would ask me like, what would be the difference? So RBAC is different from ABAC is that it focuses on the role of the user within the organization rather than on the attribute of the user or the resources being accessed. So with RBAC, you can create policies that grant permissions to users based on their role, such as architect, such as administrator, such as developer, such as tester, rather than on specific attributes of the user, such as the department or location. So you might ask me like, in which scenario would we use ABAC and in which situations we might be good to go with RBAC. So let's suppose for RBAC, let's suppose you have a group of users who are responsible for managing your AWS resources. You create an administrator role and grant this role full access to your or AWS resources, like full access to your AWS resources. You then add all the users who are responsible for managing your resources to that particular administrator group. So now you create an administrator role and grant this role full access to the AWS resources. The next step would be to add the users that you want to be held responsible for managing your resources to that particular administrator group, so that all the people in that particular group would have the same access and they would be administrators. So that's their role, and that is why we have given those permissions to them. Now when it comes back to ABAC, so let's suppose you have a group of users who are responsible for managing an AWS resource, but you only want to allow them to access certain resources during certain time of the day. So you create an ABAC policy that grants access to resources within with the tag access time equal to 9 to 5 and deny access to resources with the tag access time equal to off hour. So what happens is if they have that tag, they will not be able to access the resources. And when it comes to authentication, when it comes to security credentials, temporary security credentials is one of the best features I would feel in IAM. Temporary security credentials are a type of credential that are issued by the AWS Security Token Service. I already told you about this, STS, and they can be used to access resources in your AWS account. So these credentials consist of the access key ID, yes, and the secret access key, yes, and a session token. And they are valid for a specific duration, after which they expire and can no longer be used. So they can be useful because they allow you to grant access to your resources for a limited period of time, which can help reduce the risk of unauthorized access or misuse of resources. And they are often used in scenarios where you need to grant access to your resources to entities that are not IAM users, such as AWS services or third-party applications, or to delegate permissions to external identities. And you might ask me, are these the only benefits? I would say there are a lot of benefits of temporary security credentials. So the first thing would be assuming a role. So you can use the STS assume role API to assume a role and obtain security or temporary security credentials. So this is useful for situations when you need where you need to access resources in another AWS accounts or to delegate permissions to a third-party application. Second would be getting federation token. So you can use the STS get federation token API to obtain temporary security credentials for a federated user. So this is helpful for situations where you need to grant access to your resource to an external identity, such as a user in your corporate directory. Third one, also very important, get session token. So you can use the STS get session token API to obtain temporary security credentials for an IAM user or for the root user of your account. So this is useful for situations where you need to grant access to your resources to an IAM user or to the root user of your account. So when we talk about root account, what is the use of AWS root account and why should we never use it for our daily operations? Yes. So the AWS root account is the AWS account that was created when you first signed up for AWS. So it has the highest level of access in your AWS account and has full administrative privileges over all of the resources in your account. Yes, it has full administrative privileges over all the resources that you have in your account. And the root account is used to create and manage AWS accounts as well as to set up billing and payment information. So those two operations are the most critical operations and they are managed by the root account itself. So it is important to protect the root account because it has access to all of the resources in your AWS account and can make any change to those resources. So it is generally not recommended to use the root account for your daily operations in AWS. Instead, it is the best practice to create IAM users for yourself and for other people who need access to your AWS resources, and to grant those users the permissions they need to perform their task. So this helps to reduce the risk of accidental changes or unauthorized access to your resources and can make it easier to manage access to your resources over time. So there are a few situations where you might need to use the root account, such as when you need to set up the billing and payment information, or when you're creating or deleting AWS accounts. So however, in general, it is best to use the IAM users for your daily operations and to reserve the root accounts for tasks that require the highest level of access. Yes. So make sure that you don't use root account other than the tasks that I have mentioned. So now how do we create AWS policies or IAM policies, and how can we create, delete or validate them? So in IAM, policies are used to grant or deny access to the resources in your AWS account. So this is clear. So they are written in JSON format, I have already told you, and they specify the actions that an IAM user, group or role is allowed to perform on the resource, as well as any condition under which those actions are allowed. So all these information are put in a document format like a JSON format, and they are applied into the policy. So here are some of the steps that you would use to basically work with IAM policies. So first thing, you would create the IAM policies. So in order to create an IAM policy, you can use the IAM console, the AWS CLI or the IAM API. So using IAM API or CLI or console, you can create the IAM policy. So when creating a policy, you need to specify the actions that are allowed or denied and the resources that the policy applies to, and any condition under which the actions are allowed or denied. Now, when it comes to attaching the policy to an IAM user, group or role, so once you have created a policy, you can attach it to an IAM user, group or role. So this will grant the users, groups and roles the permissions that are specified in the policy. So let's suppose you created a policy. I have already told you, like, let's suppose you want to give access, read access to S3 bucket. So you will specify the bucket name or the bucket ARN, and you will specify the action like list object, and you will have the effect as allow so that they can be allowed to read the S3 bucket, and that policy that you create can be attached to the IAM user, group or role. Now when it comes to deleting an IAM policy, to delete an IAM policy you can use the IAM console, CLI or API. So when you delete a policy, it will no longer be attached to any user, group of role. So, but you need to remember that when you delete a policy, it will no longer be attached to any users, groups or roles, and will no longer grant any permission. By default, no user has any permission in AWS. So that's the starting point. If in case you create a policy and allow access, that's the only way a user can perform any operations, because there are customer managed policies that you create, and there are AWS managed policies that AWS already provides. So you can directly attach those AWS managed policies, or you can create your customer managed policies that like are customized for your use case. So these are the only two ways that you can actually make use of the resources in AWS. So ensure that you create policies or roles in order to use them. Now, the next thing would be how we could validate an IAM policy. So you can use the IAM console, the API, to validate an IAM policy to ensure it is well formed and does not contain any syntax errors. And IAM also provides IAM policy simulators to test an IAM policy to see how it would affect a specific user group or role. So this can be helpful for debugging policy issues or for testing changes to a policy before you apply them. So that's a very good thing. Make use of the IAM policy simulator. It's a very good tool to basically simulate the environment on which you're going to deploy that. Now let's talk about some of the best practices for using AWS IAM. So make sure that you use IAM users instead of the AWS root account. So it is generally not recommended to use the root account for your daily operations in AWS. So make sure that you create a user and assign policies to that, and then only make use of that user to perform operations on the resources that you want. Use least privilege. Yes. When granting permissions to IAM users, groups, or roles, it is important to follow the principle of least privilege. So this means granting only the permissions that are necessary for the users to perform their tasks and no more. And the next one is use IAM groups to manage permissions. So it's a very good thing. So IAM groups are a useful way to manage permissions for multiple users at once. So you can create policies that apply to all of the users in the group, which can make it easier to manage permissions for multiple users at once. So let's suppose you created a group, developer group, and one of your friends actually left the job. So now the most important thing would be to remove that user. So that's a very good thing. And the next one is also very important. It is always advised to use IAM rules for AWS services and for cross-account access. So IAM rules are intended to be assumed by authorized entities such as AWS services or external applications. They are useful for situations when you need to grant permission to resources to entities that are not IAM users. Next one is enable multi-factor authentication. Yes, for privileged users. So multi-factor authentication, or MFA, adds an additional layer of security by requiring users to provide a second authentication factor, such as a code from a hardware token or a notification sent to a mobile device in addition to their password. So along with the password, you will be asked another token that you need to provide. So that is why it is a multi-factor authentication. Because if you only use password, that's called a single factor authentication. If you use more than one, it becomes a multi-factor authentication. So it is a good idea to enable MFA for privileged users such as administrators or users with access to sensitive resources. So that's a very good thing. So if you are an administrator or someone who has access to sensitive resources, it's always better to use multi-factor authentication. And even if you don't, just use MFA. Use policy conditions to further restrict access. So that's a very good option as well, to use policy conditions to restrict access. So you can use policy conditions to further restrict access to resources by specifying conditions under which actions are allowed or denied. So for example, you might create a policy that allows users to create an EC2 instance only if they are accessing it from a specific IP address range. That's also a very good thing. Rotate your access key. So that's also very important, because you need to rotate your access key. If it is consistent and it is there for a longer period of time, it could be exposed to many sort of vulnerabilities that might expose that key. So access key consists of an access key ID and a secret key, as you already know, which are used to authenticate the identity of an IAM user. So it is a good idea to rotate your access keys regularly to reduce the risk of unauthorized access. And the next one is also very important, that is to monitor your IAM activity. So it is important to monitor your IAM activity to ensure that your resources are being accessed in a way that is consistent with your security policies. And you can use AWS CloudTrail to log and monitor IAM activity in your AWS account. So you can see which user created this instance, or which user deleted this policy or created this policy. All these things can be monitored in CloudTrail. Now let's talk about one of the very intriguing features in IAM, that is IAM Access Analyzer. So IAM Access Analyzer is a feature of AWS Identity and Access Management, or IAM, that helps you identify and understand unintended resource level public access in your AWS account. So that's a handful, but what it does, it basically analyzes resource level policies such as S3 bucket policies and IAM policies to identify resources that are publicly accessible and provides recommendation for how to mitigate unintended public access. So let's suppose you have a S3 bucket in your AWS account that is used to store sensitive data. You want to ensure that only authorized users can access the data in the bucket, isn't it? That you want to have authorized users only access the data in the bucket. However, you accidentally created a policy or a bucket policy that allows anyone to access the data. Like you had an effect equal to allow, the principal is empty and the action is S3 get object and the resource is the full S3 bucket. Then in that case, with this policy in place, anyone would be able to access the data in the bucket, which could pose a security risk. And to help identify and mitigate this issue, you could use AWS IAM Access Analyzer to scan your AWS account and identify any resource that are publicly accessible. And the Access Analyzer would help you by identifying the S3 bucket as having unintended public access and would provide a recommendation for how to fix the issue, such as updating the bucket policy to allow access to authorized users only. Yes. Overall, the AWS IAM Access Analyzer is a useful tool for helping you identify and mitigate unintended public access to your resources in your AWS account. And if you get the chance, go through this documentation or go through the documentation about IAM Access Analyzer. Read through that. It's very interesting. You can learn a lot with that. And when it comes to AWS IAM Access Analyzer, there is one more important topic that actually comes into mind. That is IAM Zone of Trust. And we must always remember what is an IAM Zone of Trust and why is it so important when it comes to security. So IAM Zone of Trust is a concept that refers to a boundary within which IAM policies are trusted to provide appropriate access to resources. So the idea behind a zone of trust is that within the boundary, users and processes can be trusted to act with the permissions they have been granted. So the idea behind a zone of trust is that within the boundary itself, the users and processes can be trusted to act with the permission that they have granted. So you are creating a trust zone. So you are trusting that if this policy is assigned and it is only allowing the read access, so you have the trust that the users and process can be trusted to act with the permissions that they have been granted. So outside of the boundary, users and process may not be trusted, and additional control may be needed to ensure that access is appropriate. So the concept of zone of trust is important for security because it allows you to define and enforce boundaries around your resources, which can help to prevent unauthorized access. So by defining a zone of trust, you can ensure that only trusted users and processes have access to your resources. And you can implement additional controls to verify the identity and permission of users and processes that are outside of the zone of trust. But here you might be a bit confused, but don't worry. So let's take an example. Like let's suppose you have a database that stores sensitive customer data. So you want to ensure that only trusted users can access the data in the database. So now to create a zone of trust around the database, you could implement the following controls. The first thing would be to use IAM policies to grant access to the database only to the trusted users and processes. Yes. So you can implement multi-factor authentication for users who need access to the database. Yes, you can do that. Or you can use security groups and network access controls to restrict access to the database to trusted IP addresses or VPCs. And by implementing these controls, you can create a zone of trust around the database that helps to ensure that only trusted users have access to the data. So overall, the concept of a zone of trust is important for security because it allows you to define boundaries around your resources and implement controls to ensure that access is appropriate. But it may not always be like sunshine and rainbows while using IAM, isn't it? So there might be some of the common issues that we might face using IAM. So let's see what they might be and how we might be able to resolve them. So I have a few examples here alongside some of the suggestions that we can use to resolve them. So what if you get an access denied error? So if we receive an access denied error when attempting to access an AWS resource, so it could be due to a number of factors. So one possible cause is that you do not have necessary permissions to access the resource. So you can check your IAM policies to make sure that you have appropriate permissions. And another possibility or another possible cause could be that you're using wrong access key. So make sure that you're using the correct access keys for your IAM users or roles. The second thing could be incorrect permissions. So if you have granted the wrong permissions to an IAM user, you may see unexpected behavior when using AWS resources. So for example, you might grant an IAM user or user permissions to read from the S3 bucket, but not to write. Then see an error when the user tries to write to the bucket. And in order to fix this issue, what do you need to do? Yes, you need to just update the IAM policies to grant the appropriate permission. So you made a mistake, you did not add the right permission. So now when the user is facing this issue, then you can just go ahead and update the IAM user policies. Now, user confusion is one more important thing. So if you have multiple IAM users or roles in your account, it can be confusing for users to remember which one to use for different tasks. And this is one confusion that a lot of people have. And in order to avoid this confusion, you can create clear naming convention for your IAM users and roles and provide clear documentation for how they should be used. And that should be helpful. Next is stale policies. Stale policies is something that we might not have used, like we might not have heard a lot of times. So if you make a change to an IAM policy and do not see the expected behavior, so it could be because the policy has not yet propagated to all of the resources that it affects. So to fix this issue, you can wait for a few minutes for the policy to propagate, or you can use the AWS Management Console to manually refresh the policy on the affected resources. So overall, the key of resolving issues with IAM is to carefully review your policies and access keys and to troubleshoot any errors or unexpected behavior. So by following best practices and keeping your IAM policies up to date, you can minimize the number of issues that you encounter when using IAM. So that's all for today's episode of Blabber Cloud by Pythoholic. We hope you found this discussion of AWS IAM to be helpful and informative. If you enjoyed this episode and want to stay up to date with the latest in the cloud security, be sure to subscribe to our YouTube channel, that is Pythoholic. We release new episodes every week featuring insights and tips from industry experts and real-world examples of how to secure your cloud environments. And if you have any questions or feedback, we would love to hear from you. Just leave a comment on the YouTube channel or this video below. And if you want to join this podcast and want to be featured on this, then please fill out the form. The link is provided on the video description below. Fill in the form and join me on this podcast. And thanks for listening, and we will see you in the next episode of Blabber Cloud. So until then, stay safe, stay healthy. It's Pythoholic signing off.